Hi, here we have two ships. They are approaching a port along straight routes at constant speeds. Okay. Initially, the two ships and the port formed an equilateral triangle. Great. So let's say this is the port and this is ship 1, this is ship 2. So port and the two ships together, they form an equilateral triangle. So let's say this is port P, this is ship S1, this is ship S2 initially, and this forms an equilateral triangle. Since it is an equilateral triangle, all these angles will be 60 degrees, right? And the equilateral triangle is of length 24 kilometers. So initially the two ships are at a distance of 24 kilometers from the port. So this whole distance is 24 kilometers, this whole distance is also 24, and this whole distance is also 24 kilometers. Okay. Now, when the slower ship traveled 8 kilometers, the triangle formed by the new positions of the two ships and the port became right angled. Now, let's say this is a slower ship. Let's say this is SS, slower ship, and this is SF, the faster ship. So now when the slower ship traveled 8 kilometers, so out of 24 it has traveled 8 kilometers, hence it will be now 24 minus 8, 16 kilometers from P. So let's say this is the new position of the slower ship. Now obviously if the slower ship travels 8 kilometers, the faster ship would have traveled more than 8. So the distance between port and the faster ship will be less than 16 kilometers. So let's say the faster ship is somewhere here, SF. So now the triangle made by port and the two ships is a right angle triangle that is given to us. Okay. So let's join these two, and this angle is a right angle. Fine. Okay. So now the question is, when the faster ship reaches the port, the distance in kilometers between the other ship and the port will be how much? Fine. So let's talk about this triangle here, the right triangle, PSSSF, the right triangle. Now this angle is 60 degrees and this angle is 90 degrees, hence this angle must be 30 degrees. So this effectively is a 30, 60, 90 triangle, correct? And we have seen this in the theory part of triangles. We have to remember the speciality about a 30, 60, 90 triangle. What is special about it? The speciality or the ratios of sides, that's what you have to remember. So if the length of the hypotenuse is known, since this is 8, this whole length will be 16, and the side opposite to the 30 degree is half of the hypotenuse. This is what we have. The smallest side, which is opposite to the 30 degree angle, is equal to half of the hypotenuse. So here the hypotenuse is 16. So the smallest side will be PSF. This is going to be half of 16, which is 8. So PSF is 8. Hence, the distance traveled by the faster ship is 24 minus 8, 16 kilometers. Right? That's what we have. So what we have is, by the time distance traveled by the slower ship is 8 kilometers, distance traveled by the faster ship is 16 kilometers. So in the same time, faster ship travels twice the distance as compared to slower ship. Hence, speed of faster ship is twice the speed of slower ship. That's the first thing. Now the question is, what we need to actually calculate is, when the faster ship reaches the port. So when the faster ship reaches the port, so distance traveled by the faster ship would be how much total? 24 kilometers. From the starting, if the faster ship travels 24 kilometers, then the smaller ship would have traveled, slower ship would have traveled half the distance. Half of 24 is 12 kilometers. So the slower ship would have traveled 12 kilometers. Hence, it would have reached halfway mark along the 24 kilometer distance. Okay. So the question is, what is the distance between other ship and the port? So other ship here is the slower ship. So since it has traveled 12 kilometers, the distance remaining will be 24 minus 12, which is 12 kilometers. Hence, option C here is the right answer. Distance between slower ship and the port is 12 kilometers now. Thank you.